Letter A. Explain free falling body. Non-physics free fall is any motion of a body when gravity is the only force acting upon it. Letter B. Solve the following problems neatly. Number 1. A stone is thrown vertically upward from the ground with a velocity of 15 meters per second. 1 second later, another stone is thrown vertically upward with a velocity of 13 meters per second. Letter A. When will the stones be at the same level? Time the stone at the same level. T is equal to time the first stone traveled. T minus 1 is equal to time the second stone traveled until the stones are at the same level. S is equal to V0 T minus 1 half 80 squared is equal to 15 T minus 1 half times 9.81 T squared. Then S is equal to 15T minus 4.905 T squared, the equation number 1. While equation 2 is S equal to 30 times T minus 1 minus 1 half times 9.81 times T minus 1 squared. So let's equate 1 and 2. S is equal to S. 15T minus 4.905 T squared is equal to 30 times T minus 1 is minus 1 half times 9.81 times T minus 1 squared. So first is let's square the T minus 1. So 15T is equal to 4.905 T squared is equal to 30T minus 30 minus 4.905 times T squared minus 2T plus 1. So let's multiply the last term. So the result will be 15T minus 4.905T is equal to 30T minus 30 minus 4.90T squared plus 9.81T minus 4.905. So let's transpose the T squared. So negative 4.905 T squared plus 4.905 T squared plus 30 plus 4.905 is equal to negative 15T plus 30T plus 9.81T. So let's cancel the negative 4.905 T squared and 4.905 T squared. So let's add the same sign. So the result will be 34.905 is equal to 24.81T. Let's multiply it to 1 over 24.81. So the result will be T equal to 1.4 seconds. Letter B. How far above the ground will the stones be at the same level? From equation 1, S is equal to 15 times 1.4 minus 4.905 times 1.4 squared. So S is equal to 11.4 meters from the ground. Letter C. Determine the time the second stone traveled until the stones are at the same level. So T2 is equal to 1.4 minus 1 second. So the result will be T2 is equal to 0.4 seconds. Number 2. A stone is dropped from a balloon at an elevation of 300 meters. 2 seconds later, another stone is projected vertically upward from the ground with a velocity of 75 meters per second. Letter A. When will the stones pass each other? So T is equal to time travel by the stones from the balloon until the stones pass each other. T minus 2 is equal to time travel by the stone from the ground until they pass each other. S is equal to distance traveled by the stone from balloon. 300 minus S is equal to distance traveled stone from the ground. S is equal to V0 T minus, plus minus 1 half gt squared. S is equal to 1/2 gt squared is equal to 1/2 times 9.81 t squared. S is equal to 4.905 t squared is the equation number 1. So 300 minus S is equal to 75 times t minus 2 minus 1/2 times 9.81 times t minus 2 squared is the equation number 2. So let's substitute equation 1 and 2. 300 minus 4.905 t squared is equal to 75 times t minus 2 minus 4.905 times t squared minus 4t plus 4. So 300 minus 4.905 t squared is equal to 75t minus 150 minus 4.905 plus 19.62t minus 19.62. So negative 4.905 t squared plus 4.905 t squared plus 300 plus 150 plus 19.62 is equal to 75t plus 19.62t. So let's cancel the negative 4.905 t squared plus 4.905 t squared. So the result will be 469.62 is equal to 44.62t. So let's divide 94.62t both sides. So the result will be t is equal to 4.963 seconds. So letter B, where will the stones pass each other from the ground? So from equation 1, S is equal to 4.905 t squared. Then S is equal to 4.905 times 4.963 squared. S is equal to 120.8 meter from the balloon. Let's substitute S to the 300 minus S, distance traveled by the stone from the ground. 300 minus 120.8 meter is equal to 179.2 meter from the ground. Letter C, compute the time traveled by the stone from the ground until they pass each other. T2 is equal to 4.963 minus 2, therefore T2 is equal to 2.96 seconds. Number 3, a stone is thrown vertically into the air at the velocity of 60 meters per second. After 4 seconds, another stone is thrown vertically into the air. Letter A, determine the time that the first ball has traveled in order to meet the second ball 120 meters from the ground. Solution: V2 squared is equal to V1 squared minus 2GS. 0 squared is equal to 60 squared minus 2 times 9.81 S. So S times 19.62 is equal to 3,600. So divide 19.62 both sides. So S is equal to 123.5 meters. So V2 is equal to V1 minus GT1. 0 is equal to 60 minus 9.81 T1. So T1 times 9.81 is equal to 60. So divide 9.81 both sides. So T1 is equal to 6.1 second. So S1 is equal to 183.5 minus 120 equals 63.5 meter. S2 is equal to 1/2 T2 squared. So 63.5 is equal to 1/2 times 9.81 T2 squared. So therefore 63.5 equal to 4.905 T2 squared. Divide 4.905 both sides. So cancel out. So T2 squared is equal to 12.9. So to cancel the T2 squared, let's square both sides. So the result will T2 equal to 3.6 seconds. Letter B, determine the time that the second ball has traveled in order to meet the first ball 120 meters from the ground. T3 is equal to T1 plus T2 minus 4. So T3 is equal to 6.1 plus 3.6 minus 1. So T3 is equal to 9.7 second minus 4. So T3 is equal to 5.7 seconds. Let us see what initial velocity must the second ball have in order to move the first ball 120 meters from the ground. S3 is equal to B3 times T3 minus 1 half GT3 squared. So 120 is equal to V3 times 5.7 minus 1 half times 9.81 times 5.7 squared. So 120 is equal to V3 times 5.7 minus 159.4. Then 120 plus 159.4 is equal to V3 times 5.7. So therefore 279.4 is equal to V3 times 5.7. And divide 5.7 both sides. So V3 is equal to 49 meters per second. Number 4. A stone is thrown vertically upward with an initial velocity of 3 meters per second from the top of a tall building. The stone strikes at the ground 4 seconds later. Letter A. What is the maximum height reached by the stone above the building? V2 squared is equal to V1 squared minus 2GH. So 0 is equal to 3 squared minus 2 times 9.81h. 19.62h is equal to 9. Then divide 19.62 both sides. So the result is h is equal to 0.459 meters. Letter B. What is the height of the building? Then solution V2 is equal to V1 minus GT1 is equal to GT1 all over G. Cancel G, then equal to V1 minus V2 all over G. So T1 is equal to V1 minus V2 all over G. T1 is equal to 8 minus 0 all over 9.81. Then T1 is equal to 0.31 seconds. So T2 is equal to 4 minus 0.31. Then T2 is equal to 3.69 seconds. Is equal to 1 half GT2 squared. H is equal to 1 half times 9.81 times 3.69 squared. H is equal to 66.79 meters. So H is equal to H minus F. H is equal to 66.79 meters minus 0.459 meters. H is equal to 66.331 meters. Let us see what is the velocity of the stone as it strikes the ground. So V3 squared is equal to V2 squared plus 2GH. So V3 squared is equal to 02 plus 2 times 9.81 times 66.79. So therefore V3 squared is equal to 13 10.42 to the power of 1 half. So V3 is equal to 36.20 meters per second. Number 5. A ball is thrown vertically up from the ground with a velocity of 90 meters per second. How long must one wait before dropping a second ball from the top of a tower 180 meters high if the two balls are to pass each other 60 meters from the top of the tower? Solution. S is equal to V0 times T1 minus 1 half G times T squared. So 120 is equal to 90 T1 minus 4.905 T1 squared. So 4.905 T1 squared minus 9 T1 plus 120 is equal to 0. So using quadratic formula, negative V plus negative square root B squared minus 4AC all over 2A. So T1 is equal to negative quantity negative 90 plus minus square root of negative 90 squared minus 4 times 4.905 times 120 all over 2 times 4.905. T1 is equal to 90 plus minus 75.8 all over 9.81. So T1 is equal to 16.90 seconds. So So T2 is equal to 1 half GT2 squared. So 60 is equal to 1 half times 9.81 T2 squared. 60 is equal to 4.905 T2 squared. Divide 4.905 both sides. So T2 squared is equal to 60 over 4.905. So to the power of 1 half. So cancel T2 squared. So T2 is equal to 60 over 4.905. Therefore, T2 is equal to square root of 12.43. T2 is equal to 3.5 seconds. So T3 is equal to T1 minus T2. T is equal to 16.19 minus 3.5. So T3 is equal to 13.4 seconds.